Cam locks can present safety hazards in school environments if not properly implemented and maintained. One significant concern is electrical shock. Cam locks provide a means for disconnecting and reconnecting electrical equipment, and if these connections are not securely made or if the cam lock itself is damaged, it can create an electrical hazard and potentially shock anyone who comes into contact with it. Another hazard is arcing. When a cam lock is disconnected under load, it can create an electrical arc. This arc emits sparks and heat, posing a fire risk. Loose connections are another worry. If cam locks are not adequately tightened, they can loosen over time, leading to electrical arcing and potential fire hazards. Unauthorized access is also a concern. Cam locks can allow unauthorized individuals to disconnect or reconnect electrical equipment, which could create a safety risk or damage the equipment. To mitigate these safety concerns, several alternatives to cam locks can be considered. Firstly, lockable connectors can be used. Lockable connectors provide a more secure connection than cam locks, preventing accidental or unauthorized disconnection. Secondly, hardwired connections can be implemented. Hardwiring the equipment directly to the electrical panel is the most secure option, as it eliminates the risk of loose connections or electrical arcing. Thirdly, proximity sensors can be employed. Proximity sensors can detect when equipment is being moved and automatically disconnect it from the power source, reducing the risk of electrical hazards. Fourthly, supervised access can be enforced. If cam locks must be used, ensure that they are properly installed and maintained. Supervisors should regularly check the connections and prevent unauthorized access to the equipment. Additional recommendations should be followed. Use cam locks only if all other options are impractical or not feasible. Choose cam locks with robust construction and durable materials. Install and tighten cam locks securely, following the manufacturer's instructions. Regularly inspect cam lock connections and replace any damaged or worn components. Train all authorized personnel on the safe handling and usage of cam locks. Implement a lockout-tagout procedure to prevent unauthorized access to cam locks. When working with electrical systems, especially those involving dimmer control boxes rated at 120 volts and 80 amps three-phase, several key electrical concepts and safety procedures should be carefully considered. Firstly, understanding three-phase power is crucial. Three-phase power is a type of alternating current (AC) electrical power distribution that uses three conductors, or wires, to deliver power. This configuration provides a more efficient and stable power supply compared to single-phase systems, particularly for high-power applications. The 120 volts rating indicates the voltage level at which the equipment operates. The 80 amps rating signifies the maximum current the equipment is designed to handle. When dealing with high-current applications, the selection of appropriate wiring and connectors is critical for safety and performance. Secondly, selecting appropriate wiring. The use of number 2 sulfur-olefin wires, so wires, with a length of 18 inches extending from the back of the dimmer control boxes requires careful consideration. Number 2 American wire gauge, AUG, wire is a specific size of electrical conductor, and its current carrying capacity must be sufficient for the 80 amps load. The National Electrical Code (NEC) provides guidelines for the ampacity of various wire sizes based on factors such as insulation type, temperature rating, and installation method. It is essential to consult NEC Table 310.15 B16 or more recent applicable tables to determine the appropriate wire size for the specific conditions. For example, if the number 2 SO wire has a temperature rating of 75 degrees Celsius and is installed in a conduit, it may have an ampacity of around 95 amps, which would be suitable for an 80 amps load. However, if the temperature rating is lower or the installation conditions are different, the ampacity may be insufficient, necessitating a larger wire size. Thirdly, connector selection. The manufacturer's recommendation of using cam locks for terminating the wires indicates that these connectors are designed to handle the high current and provide a secure, reliable connection. Cam locks are commonly used in temporary power distribution systems, such as those found in entertainment venues and construction sites. They offer a quick and easy way to connect and disconnect high current cables. However, as previously discussed, they also pose potential safety hazards if not properly installed and maintained. The alternative of using a Hubble plug set, while more expensive, may offer enhanced safety features, such as a more robust locking mechanism and better protection against accidental disconnection. When selecting connectors, it is essential to consider factors such as the voltage and current rating, environmental conditions, and ease of use. The connectors should be listed by a recognized testing laboratory such as Underwriters Laboratories, or ETL-SEMCO, to ensure that they meet safety standards. Fourthly, safety considerations in schools. The installation of electrical equipment in a school environment requires strict adherence to safety regulations and best practices. Schools are considered sensitive environments due to the presence of children and the potential for unauthorized access to electrical equipment. Therefore, all electrical installations must comply with the National Electrical Code and any local electrical codes. The use of cam locks in a school setting may raise concerns about unauthorized access and the potential for tampering. It is crucial to implement measures to prevent unauthorized access, such as locking the electrical panels and providing training to authorized personnel. Additionally, regular inspections and maintenance are essential to ensure that the electrical equipment is in good working condition and that all connections are secure. Fifthly, lockout-tagout procedures. A lockout-tagout (LOTA) procedure is a safety procedure used to ensure that dangerous machines are properly shut off and not able to be started up again prior to the completion of maintenance or servicing work. It requires that hazardous power sources be isolated and rendered inoperative before any work is started on the equipment. In the context of dimmer control boxes and cam locks, a lockout-tagout procedure would involve disconnecting the power supply to the dimmer control boxes, locking the disconnect switch in the off position, and attaching a tag indicating that the equipment is out of service. This procedure prevents accidental energization of the equipment during maintenance or repair work. Sixthly, grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, preventing voltage differences that could cause electric shock. In the case of dimmer control boxes, the metal enclosure should be properly grounded to the building's grounding system. Additionally, all metal conduit and other metal parts of the electrical system should be bonded together. Seventhly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that could cause overheating, fire, or equipment damage. The dimmer control boxes should be protected by appropriately sized circuit breakers or fuses. The size of the overcurrent protection device should be based on the ampacity of the wiring and the rating of the equipment. It is essential to consult the National Electrical Code and the manufacturer's instructions to determine the correct size of the overcurrent protection device. Eighthly, arc flash hazard. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can generate intense heat pressure waves and molten metal, which can cause severe burns, injuries, and even death. Working on or near energized electrical equipment can increase the risk of arc flash. Therefore, it is essential to take precautions to minimize the risk of arc flash. This may include energizing the equipment before working on it, wearing appropriate personal protective equipment (PPE) such as arc-rated clothing and face shields, and following safe work practices. Ninthly, personal protective equipment. When working with electrical equipment, it is essential to wear appropriate personal protective equipment to protect against electrical shock, arc flash, and other hazards. PPE may include insulated gloves, safety glasses, arc-rated clothing, and insulated tools. The type of PPE required will depend on the specific task and the potential hazards involved. It is essential to inspect PPE before each use to ensure that it is in good condition and that it provides adequate protection. Tenthly, training and qualifications. Only qualified and trained personnel should be allowed to work on electrical equipment. Qualified personnel have the knowledge, skills, and experience necessary to perform electrical work safely. They should be familiar with the National Electrical Code, local electrical codes, and safe work practices. Training should include topics such as electrical safety, arc flash hazard awareness, lockout-tagout procedures, and the proper use of personal protective equipment. 11th, documentation and labeling. All electrical equipment should be properly documented and labeled. Documentation should include wiring diagrams, equipment specifications, and maintenance records. Labeling should identify the voltage, current, and other important information about the equipment. Proper documentation and labeling can help prevent errors and ensure that the equipment is properly maintained. 12th, regular inspections and maintenance. Regular inspections and maintenance are essential for ensuring the safety and reliability of electrical equipment. Inspections should be conducted by qualified personnel and should include a visual examination of the equipment, testing of electrical connections, and verification of grounding and bonding. Maintenance should include cleaning, lubricating, and replacing worn or damaged components. 13th, emergency procedures. It is important to have emergency procedures in place in case of an electrical accident. These procedures should include steps to take in the event of an electrical shock, arc flash, or fire. All personnel should be familiar with these procedures and should know how to contact emergency services. 14th, National Electrical Code compliance. The National Electrical Code is a comprehensive set of standards for electrical installations. Compliance with the National Electrical Code is essential for ensuring the safety of electrical systems. The National Electrical Code is updated every 3 years, so it is important to stay up to date with the latest requirements. 15th, local electrical codes. In addition to the National Electrical Code, many local jurisdictions have their own electrical codes. These codes may be more stringent than the National Electrical Code and may address specific local conditions. It is important to comply with both the National Electrical Code and any applicable local electrical codes. 16th, working with 120 volts versus higher voltages. While 120 volts is considered a relatively low voltage, it can still be dangerous. Contact with 120 volts can cause electrical shock, burns, and even death. Higher voltages such as 277 volts or 480 volts are even more dangerous and can cause more severe injuries. It is important to take appropriate precautions when working with any voltage level. 17th, three-phase versus single-phase systems. Three-phase power systems are more complex than single-phase systems. They require specialized knowledge and equipment to install and maintain. When working with three-phase systems, it is important to understand the phase relationships and to ensure that the system is properly balanced. 18th, using appropriate test equipment. When working with electrical equipment, it is essential to use appropriate test equipment to verify that the equipment is de-energized before working on it and to troubleshoot any problems that may arise. Test equipment may include voltage testers, continuity testers, and insulation resistance testers. It is important to use test equipment that is properly rated for the voltage and current levels being measured. 19th, avoiding working alone. It is always best to avoid working alone on electrical equipment. If possible, have another person present who can assist in case of an emergency. This person should be familiar with electrical safety procedures and should know how to contact emergency services. 20th, remaining vigilant and aware. Electrical work can be dangerous, so it is important to remain vigilant and aware of your surroundings at all times. Pay attention to potential hazards and take steps to mitigate them. If you are unsure about something, ask for help. When evaluating the safety of cam locks versus hubble plugs, consider the specific application and the potential risks. Cam locks are generally less expensive and easier to install, but they may be more prone to accidental disconnection and tampering. Hubble plugs are more expensive and may require more specialized installation, but they offer a more secure and reliable connection. In a school environment, where safety is paramount, the additional cost of hubble plugs may be justified by the enhanced safety features. Ultimately, the decision of whether to use cam locks or hub plugs will depend on a variety of factors, including cost, safety requirements, and the specific application. It is important to carefully weigh all of these factors before making a decision. Remember, electrical safety is a critical aspect of any electrical installation. By following these guidelines and best practices, you can minimize the risk of electrical accidents and ensure a safe working environment.